So there are two viewpoints on the derivative. The first is geometric. The way you think about this is you have a curve and you draw the curve, and then you have a point where you want to calculate the instantaneous rate of change, and you can do that by sketching a line. And the slope of this line at this point is what's called the derivative, or f prime of a. So that's the first interpretation. And the second interpretation, which is related, is based on the idea of taking the average rate of change over a very small interval, and then taking that expression and wrapping it and taking the limit as h approaches 0 of that expression. So this slope of the tangent line and this limit as h approaches 0 of f of a plus h minus f of a all over h, these are exactly the same thing. It's just that one is the visual way of seeing it, and the other is the formula-based way of seeing it. Now, we have been over and over and over again calculating these for specific functions and specific values. Let's look at some different types of functions that we could do. What's the most basic type of function anybody could ever think about? Like the most boring function in the history of the world. F of x is equal to 3. This is a horrible f of x is equal to 3. This is a constant function. Now, I think that we should be able to say, based on the graph of f of x equal to 3, it's just a completely flat line. What is the slope of this at any point? Like, what is f prime of 1? 0. Why? Yep, the slope here is 0. F prime is the slope. Now, what is f of 1? 3. Okay. What about at -2? What is f prime of -2? 0. What about f of -2? 3. And it doesn't matter what value you pick. So we actually have a function where if you plug in any number and ask what is the instantaneous rate of change, what would the f prime of that value be? F prime of x, the slope, is always going to be equal to, well, here you told me it was 0, here you told me it was 0. Is it always 0? Because this function doesn't change at all. This function never has a non-zero slope. So the slope here is always 0. Geometrically, I can see that the slope here should always be 0. Now I want to ask, what if I look at f of x plus h minus f of x all over h, and I look for the limit as h approaches 0 of that? Does it matter what x is? Does it matter? It doesn't matter what x is here. This is f of x plus h. F of x plus h is 3. What's f of x all over h? Can I plug in h equals 0? Yeah, that's going to be a problem. So this is going to be the limit as h approaches 0 of 0 over h. But now I look at this and I say, well, it doesn't actually matter that I can't plug in h equals 0, because all that matters for a limit is what the trend is. This curve, if I looked at it and sketched it on the graph, if I looked at 0 over h and I was letting h get smaller and smaller and smaller, it would actually be undefined at h equals 0, but everywhere else it would take the value 0. So what is this limit? They have something called the all but one point principle, which is if your function or your expression takes a value at all except a single point, then you can still take the limit at that point, and it's going to be the same value as the other thing. So for a constant function, we have this geometric interpretation that this slope should always be 0. And then we have these limit-based calculation, which says that the slope is 0. So here we're looking at a linear function, L of x equals 5x plus 1. And here you said it always has the same rate of change. That's one of the things about linear functions, is they always have the same rates of change. So what is L of 1? Is 6. What's L prime of 1? 5? It's 5. Well, because what's the slope here? The slope, if I draw my line here, the slope is 5, right? When I trace my tangent line, I'm actually tracing the line itself. L prime of 1 would be 5. Now, what about at x equals -2? What's L of -2? -9. What's L prime of -2? 5. Does it matter where you look on this curve? Will the slope ever change at any point? No, the slope will never change. So L prime of x will be equal to 5, no matter where the value of x is. So that's cool. And now for this line, we have this geometric interpretation that the slope should be equal to the slope of the line. And now I'm wondering if we can calculate it. So I'd be looking at the limit as h approaches 0 of L of x plus h minus L of x all over h. And so I'm going to give you a few moments to calculate this.